friends, welcome to Jitesh classes. Today we are starting the fluid statics part 5. Now I'll explain hydraulic lift. In last chapter I explained about Pascal's law. Today hydraulic lift and pressure distribution in accelerated fluids. I'll explain those. Accelerated vessel. Okay, now we are starting with hydraulic lift. Hydraulic lift, this is a machinery. By using it, we use lifts like cars and those all in showrooms. You may see that those will be lifted like in manufacturer companies. These cars and those will be bring up by using these or some other will be. But I am saying now about hydraulic lift. This is containing liquid. And here this is having a cross sectional area A1, and here this cross sectional area is A2. Then here if we apply a force F1, if we apply a force F1, then the pressure, then the pressure F1 by A1, the pressure is transmitted in the liquid equally. So if the pressure is transmitted equally in this machinery, then what will happen here? With some force, something will push it. See, that pressure will act here also. So with a force F2, it will push, or we can say that to stop. See, our force F2 is acting to push it outwards. See, that pressure here also that pressure is acting, and that is pushing that with the force F2 with that cross sectional area A2. So it is pushing up F2, or we can say that our force F2 should be acted. Our force F2 should be acted downwards to keep it in equilibrium, to not make this piston move upwards. So we can say F1 by A1 is equals to F2 by A2. And F2, the force should be acted to keep that in equilibrium, or the force is acted to make the force acted outwards to push it outwards is F2. That F2 is equals to F1 into F1 by A1 into A2. This is hydraulic lift. And now pressure distribution in accelerated liquids. Pressure distribution in accelerated vessels containing liquid. Pressure distribution in accelerated vessels. Accelerated vessels containing liquid. See, those will be in horizontal direction and vertical direction. Now I will explain in horizontal direction first. X-axis. See, if we take a liquid, say a vessel we are taking, and in that, when it is at rest, then it will be like this. When it is accelerated horizontally, then due to the pseudo force it will be Newton's laws of motion, pseudo force. That if it is accelerated in this direction, then the pseudo force is acting in the backward direction, MA. This is MA, or we see MA. It is acting in the backward direction. Due to that, it will come like this. So here see, if we take a small water H2O molecule, water molecule here, and its Mg is acting downwards and Ma is acting in this direction, the pseudo force. Both are acting in this direction, and this is theta. Theta is, see here, this is theta. How much it is? This is theta with the horizontal. This is theta. So if this is theta, here this will be also theta, and then this is also theta due to alternate interior angles, and here that one. See, and here this is mg sin theta. This is mg cos theta. This one is Ma cos theta. Ma cos theta. And this will be Ma sin theta. But we don't need those all. We will get the result with these two only. See, if this is water molecule is, see if it is accelerating here, see the liquid is accelerating in this direction. Then if it is accelerating with the same constant acceleration, the water will be in that position. It won't change, like this, fluctuations won't come. It is accelerating, then it will be in the same, if it is with same acceleration. So here it is stable. Then these two are equal, then only that will be at that point. So those two are equal. Ma cos theta is equals to mg sin theta. Mg sin theta. M and M get cancelled. Tan theta is equals to sin theta by cos theta is tan theta, and this is equals to A by G. This is the result we need to get, and we got that. And theta is tan inverse A by G. Now, in a closed vessel, I will explain that afterwards. Now we will explain in y-axis, vertical direction, accelerated in vertical direction. See, y-axis. This is a vessel containing liquid up to height h, accelerated upwards, then pseudo force is acting downwards. This is P ATM. We will take that P ATM. This is P ATM, and this one is P A at this point, and cross sectional area is A1. A1, because cross sectional area, or we will take the cross sectional area small a. So mg is acting downwards here, and here cross sectional pressure into cross sectional area is equals to force. So F2, here F2 is equals to, and here F1 is equals to P ATM into the cross sectional area, and here this is PA into cross sectional area is F2 here. See these in that only, these three forces mg, ma and F1 are acting downwards, and this is acting upwards. So we can equate those by F2 is equals to F1 plus ma plus mg. We know, see this has this is density, this has a density rho, this has a density rho. So m is equals to, we know that m is equals to density into volume. Density is equals to mass by volume, mass is equals to density into volume. So volume we know that it is area into height. So rho small h is the mass here. Now we'll substitute those values, all those values. P A into A is equals to P ATM into A plus rho AH. Oh, we took acceleration also. No. Okay, we'll take the area, capital A1. So this is A1. This is also A1. A1. Okay. A1 and A1. See, rho A1 into H into A plus G. A1, A1. We'll take common and we'll cancel with this, and PA is equals to PATM plus rho, see, H rho into effective gravity. G effective gravity means net gravity. Like that acceleration we can take A plus G is effective gravity here. A plus G. We will call that as effective gravity. And now in downward direction, if it is accelerated in the direction, downward direction, see, vessel containing liquid, height h, accelerating downwards, A, upward MA. Here force, we know that I already said F1 plus F1 is equals to PATM into area, cross-sectional area is equals to A1, and this here PA is the pressure here at this bottom, and mg is acting downwards. See, this is into A1 is the force here, and F2 is equals to PA into A1. We got all the forces here. This is density rho. We know mass is equals to rho AH. Mass is equals to rho AH. See here, two forces are acting upwards and two forces are acting downwards. We will equate those. F1 plus mg. F1 plus mg and F2 plus ma. F2 plus ma. So here we will substitute all those values here. PATM into A1 plus rho A1 into H. Rho A1 into H is equals to P A into A1 plus rho A1 into H into A. This we will take the here common and here common, or will get cancelled, and at last we have PA is equals to PATM plus H rho into G minus A. It will come this side. Oh, sorry, here G is missing. Sorry. Here it will come, and see, we will transport this here. So G minus A. Here G minus A is the effective gravity. G minus A is the effective gravity. G minus A. Now, pressure distribution in a closed vessel. See, in an accelerated closed vessel means no atmospheric pressure is acting there. If no atmospheric pressure is acting there, see, accelerated accelerated closed vessel, accelerated closed vessel. Then in that we'll take in x-axis, that direction will be in x-axis. In x-axis here we'll take a accelerated vessel which is closed. No atmospheric pressure is acting up from upwards or anywhere. No atmospheric pressure is acting. So here what it is accelerated in this direction. So MA here, MA in this direction, we know that. Wait, this length is L, down here length, and this is height H, and here it will be P max. See, because it will be P max because see, MA is acting in this direction and MG is acting in this direction. If we take apart MG is acting in this direction, so the F net will be in this direction, F net, and this F net plus the pressure. See, okay, this F net we know that already, F net, and here see this here, the pressure, we can find the pressure here also. Here in different points we can find, but the important point is here. After seeing that first one, after completing the first, I said already, those in accelerated, I said starting now, those after seeing and after knowing those, you can directly derive those. So I will say only this one, that P max is equals to, at this point, any point, you can take that B anything, something, we will write P max. P max is equals to 0 because the atmospheric pressure is 0 plus H rho G plus rho L A. This density is rho. See, this is L. If it is if it is going in this direction, the displacement is L. If it is going in this direction, the A, here the acceleration is A, length is L, means height, like that, length is L. See, due to that also, the pseudo force is acting at this point. If it is moving in this direction, the pseudo force is acting in this direction at this point, and that with MA and this MA means that rho LA, that pressure is rho LA is acting in this direction, the pseudo pressure, like that, pressure is acting in this direction, rho LA, and the normal gauge pressure is H rho G, that is acting at this P max point. So the P max is equals to H rho G plus rho LA. In common, P max is equals to rho common H G plus rho A. This is the pressure distribution in a closed vessel, and what I explained today, I recall this. The first one, that is hydraulic lift. Hydraulic lift, that's a machinery to lift huge to lift huge bodies in that it is containing liquid. If pressure F1 is acted in this one end with cross-sectional area A1, the pressure is transmitted equally in all those. I explained in Pascal saw that one, and that here is pushing upwards with a force F2. So F2 is equals to F1 by A1 into A2. And next I explained this one, pressure distribution in x-axis. That one is equals to all we know, I already explained, Py at that point, and this one P max at this in closed vessel. That's it. If you like my explanation, kindly like, share and subscribe to my channel.